Okay, in this video we look at congruent and similar triangles, and we'll also look at transversals cut in parallel lines. Okay, the first thing we look at is congruent triangles. And congruent triangles just means triangles that are the same. How do we know triangles are the same? Well, there's three tests we can do. We can see if two triangles have two sides that are the same and one angle. If they do have two sides and one angle that are the same, we can say they are congruent. Okay? And we denote that by side, angle, side, SAS. We can also do another test. If they have two angles the same and one side, then they're also congruent. Angle, side, angle, ASA. And if they have three sides that are the same, then we can say they're congruent, and that's denoted by side, 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 which is SSS. So if you look at this triangle, let's do the test. Let's see if we can find three sides that are the same, or two angles on one side that is the same, or one angle and two sides that are the same. So triangle A has a length of 5 here, and a 5 there. So we definitely have a side. And we have an 80-degree angle here, and we have an 80-degree angle here. So we definitely have an angle. And we have a 30-degree angle here and a 30-degree angle here, so we have another angle. So we have two angles and a side, so we have angle, side, angle, which means A and B are congruent. Okay. Notice that in this, nowhere does it say three angles. If we have three angles, if three angles are the same in triangles, they might be congruent, but we can't say for definite. They may not be, and I'm going to prove it here. In similar triangles, we're looking for three angles that are the same. So have a look at triangle A, which is here, and triangle B. They have three angles that are the same. We have 70 here, 70 here, 65 here, 65 here, 45 here, 45 here. Okay. And it doesn't, like, just because the 70 is on top here, the 70 is on top here, and 65 is here, and 65 is here, and 45 is here, and 45 is there. And that actually doesn't make a difference. As long as we can find three angles that are the same, we can say they're similar. They may be congruent, but they may not be. Okay? In this case, these angles are definitely not congruent because one is smaller than the other, so they're not the same. So what similar triangles are is having the same angles, yet one may be bigger or smaller than the other. Now we're going to look at ratios in parallel lines. We've three parallel lines here in the red, here, here, here. And I have a transversal that's cutting it here. And the length of the transversal here between these two parallel lines is 3. And the length here is 1. The length here is 4. The length here is x. And I'm going to find out what x is. So here's what I do. I look at this transversal. I'll put the big side over the small. Okay, so there's a ratio, 3 is to 1. And I can say that equals, and now look at the big side on this transversal, 4 over x. So to find out what x is, we can cross multiply. So we have 4 equals 3x, divided by 3, divided by 3, we get 4 over 3 equals x. Okay, so this here, x, is 4 over 3, which is, if we want, 1 and 1/3. Okay. Likewise here, okay, let's just look at this. Put this in red. So, actually, let's rewind a sec. So in this we have a triangle, and then there's a line cutting across it, and this line is parallel to this line. Technically, this is two parallel lines with two transversals cutting through it, just like this. Okay, technically it's the exact same. Watch. If the base line, if I just say, well, that's that's a parallel line. Well, here's one transversal, and here's the other transversal. The only difference between this here and this is that these actually meet here. Okay, this doesn't. But if I continue this down, and I just stopped it here, well, actually there's a triangle. Okay, so it's actually it's the exact same. So the exact same rules apply. So I want to find out what x is. Okay, let's see. Again, we will take this transversal here, and I will go the 4 on top, I suppose, and the x on the bottom, and that equals the 6 on top, the 12 on the bottom. Cross multiply, we get 6x equals 48, divide by 6, divide by 6, we get x equals 8, so x is 8, so that's 8. Okay.